Emily buys a pack of 12 bottles of water. The pack costs £5.64. Emily sells all 12 bottles for 50p each. Work out her percentage profit. Give your answer correct to one decimal place. So profit is a bit like percentage change, and we're going to do the change over the original times by 100. Now, for the context of this question, that's slightly different. Change over original times by 100. So the change is going to be the extra amount of money that she makes. So if she's doing 12 bottles and she's selling them each for 50p, let's do 12 times 0.50, since that will get my answer straight into pounds. And that is £6. So she's made £6. Now the extra money that she's made, the change, is going to be how much extra that is, and that's 36p. So I'm going to put 0.36, that's the extra money, over the original. Now the original is how much money she spent out in the first place, and that's £5.64. And then to get that as a percentage, we're going to times it by 100. So typing that in my calculator, I'm going to use my fraction button, 0.36 over 5.64 multiplied by 100, and that gives me 6.38297. We've been asked to round it to one decimal place, so 6.4% profit. Okay, question number 4. There are only blue cubes, yellow cubes and green cubes in a bag. There are twice as many blue cubes as yellow and 4 times as many green cubes as blue. Hannah takes at random a cube from the bag. Work out the probability that Hannah takes a yellow cube. So looking at this, I can see that yellow is actually the smallest amount. Yellow gets doubled to get the amount of blue, and then blue gets multiplied by 4 to get the amount of green. So let's write the ratio blue, yellow to green. So we know that for every 1 yellow, there's twice as many blue. So that's going to be 2 blues. We don't know how many there are, but we know that they're in this ratio. And then for the greens, it's 4 times as many green as there are blue. So whatever blue is, we need to times it by 4, and that gives us 8 for green. So what is the probability of taking a yellow cube? Well, we don't know if this is 1, 2, and 8, or maybe it might be 2, 4, and 16. That still satisfies all of the conditions set out above. But what we do know is it doesn't really matter, because if I look at how many a yellow, or what fraction of yellow, it's going to be 1 out of 11. And then for this, if I did it on this one, it would be 2 out of 22, which is exactly the same. So it doesn't matter, 1 over 11 would be the answer for that one. Okay, question number 6. P cubed times p to the power of x equals p to the power of 9. So we know that when we multiply, we add the powers. So I'm looking for a number here that 3 add something would equal 9, and that is going to be 6. So that power would need to be 6. P cubed times p to the power of 6 equals p to the power of 9. And then for the next one, we have a power of a power. So 7 squared to the power of something needs to equal 7 to the power of 10. And we know that when we have a power of a power, we times those powers together. So y would need to be 5. 2 times 5 is how we get 10. Okay, and then this one, a little bit trickier. 100 to the power of a times 1000 to the power of b can be written in the form 10 to the power of w. So they're saying it can be rewritten to just have 10 as the base number. Show that w equals 2a add 3b. Okay, so I know that I need to change both of these parts to be 10 to the power of something. I know that 100 is 10 squared, so I'm going to change 100 to be 10 squared, but that still needs to be raised to the power of a. So I can see there that that still has to have the power of a on it, and then times that by, now 1000 is 10 cubed. So I'm going to change the 1000 to be 10 cubed, and that still needs to be raised to the power of b. Now we saw in the question above that a power of a power means you times those powers together. So this is going to be 10 to the power of 2a, because we're timesing them, times 10 to the power of 3b. And we know that when we multiply, we add the powers. So this is altogether 10 to the power of 2a add 3b, which is exactly what they've asked us to show. Okay, question number 8. Use your calculator to work this out. So the first thing we're going to be pressing in our calculator is the square root button, and then we're going to be pressing the fraction button. Now, if you press them the other way round, you're going to end up with the square root just on the top of the fraction, which isn't what we want to happen. So you're going to press the square root first, and then press your fraction button, and we're going to type sine 25. Now, you'll notice when you press sine, the bracket opens, and we need to shut it after the angle 25. add sine 40, and then again shut that bracket after the 40. Press your down arrow to come down to the underneath. I'm sorry you can't see this, but hopefully my explanation's okay on audio. Shut the bracket on cos 25, and then minus cos 40, and again shut the bracket, hit equals, and write down all of the figures. So we've got 2.75603957 on my scientific calculator, and then for part B we're asked to write it to 2 decimal places, which would be 2.76, because I would stop there, check the next number, and it rounds up, so this 5 becomes a 6. Okay, great. Question number 10. Here is part of a distance time graph for a car's journey. Between which 2 times does the car travel at its greatest speed? So speed is distance divided by time. So it's the y divided by the x. So it's actually on a distance time graph going to be the gradient. So the speed on this graph is the gradient. Where is my gradient the steepest? That's what they're actually asking me. And it's this part here, it's this line. This line is the steepest part of that journey. So between 0 and 20 seconds, because the gradient is the steepest, work out this greatest speed. So if you think about your speed, distance, time triangle, this will make sense as well. If we cover up the S, to find the speed, it's going to be distance divided by time. So we're going to do the distance divided by the time. So if I want to know what the gradient is, I always make a triangle and I do rise divided by run. So the rise is how much it's gone up, which in this case is from 0 up to, we can see that this is 300 here, and that's 20, 40, 60, 80, up to 100. So that's going to be 360 up, and we're dividing that by 20. Rise over run gets you the gradient, or in this case it's going to be distance divided by time. So it's 360 divided by 20, which is the same as 36 divided by 2, which is 18. And we had a calculator anyway, but there we go. 18 metres per second. Okay, question 12. RS and ST are 2 sides of a regular 12-sided polygon. So you can kind of imagine that the rest of this shape is coming round like that, but drawn better. Okay, RT is a diagonal of the polygon. Work out the size of angle STR. So remember that angles in a triangle add up to 180, and angles in a quadrilateral, a 4-sided shape, add up to 360. Angles in a pentagon add up to 540, and every time you add a side, you add another 180 degrees. Now, if you forget the formula, that's always a good thing to know, because you could just keep adding 180 until you get up to a 12-sided shape. But in this case, it's going to be easier to use the formula. So a 12-sided shape, we're going to put into our formula, and the formula is n minus 2 times by 180 is the total interior. So how many angles inside the shape, or how many degrees inside the shape altogether. Since this is a 12-sided shape, we're going to do 12 take away 2, which is 10 times 180. And that means that in a 12-sided shape, the angles need to add up to 1,800. So if you imagine the rest of this shape being here, each of these angles inside, that one, that one, that one, and so on, would need to add up to make 1,800. And since it's regular, all of the sides are the same length. So all of the angles are the same size as well. So we can go ahead and do 1,800 divided by 12, because there are 12 same size angles inside this shape altogether, and that is 150 degrees. So that means that I now know, getting rid of all of that again, that angle at S is 150 degrees, because that would be one of the angles that would make up the bigger shape. And now I know that also these 2 sides are the same length, hence those little lines, that's what that means. And so these 2 angles are going to be the same. This is an isosceles triangle. So I'm going to do 180, take away 150, which is 30, and then do 30 divided by 2. So each of those angles is 15 degrees. So they asked me for angle STR, S to T to R is that angle there, and that is 15 degrees. Okay, question number 14. On the grid, shade the region that satisfies all of these inequalities. So when we're shading regions, we need to think, what does the line y equals 1 look like? What does the line x add y equals 5 look like? And what does the line y equals 2x looks like? So because they are all greater than or less than and not equal to, So we're going to use dotted lines. So we've got the line y equals 1. Now if we were just drawing y equals 1, we'd draw a solid line, but we're doing inequalities and I want to draw when y is bigger than 1. So we're going to draw the line y equals 1, but we're going to use a dotted line for that. Y equals 1 is the line that goes through 1 on the y-axis. Every single coordinate on that line has a y-coordinate of 1. So that is the line y equals 1. Now we want y to be bigger than 1. So which side of that line has y-coordinates that are bigger than 1? It's going to be up here above. And everything below the line we don't want, because all of these coordinates on that side of the line have a y-coordinate that is less than 1. We want when the y-coordinate is bigger than 1, which is going to be on top. So we've drawn the line and we've shaded the right side of it that we don't want. Okay, next one, x add y is equal to 5. Now the line x add y is equal to 5 is just a line with coordinates that are made up of two numbers that add together to make 5. So for example, 1, 4 is going to be on this line because its x coordinate add its y coordinate, add together to make 5. The point 2, 3 is on this line. The point 5, 0 is on this line, and so on. As long as the x and the y coordinate add together to make 5, and they are all of these points here. So that makes the line x add y equals 5, and I'm going to join that up again with a dotted line, and that's because it's less than 5, not less than or equal to 5. And I want to shade in the right side. Now I want x add y to be smaller than 5. So let's just look at the origin, for example. At that point, is 0 add 0 less than 5? Yes, it is. And every coordinate on this side of the line has an x and a y coordinate that would add together to be bigger than 5. So we don't want any of that. So I want to shade in everything up here. I'm not interested in that side of the line. This is the side that I want. Okay, there we go. And now I've got one more line to do, and I'm drawing the line y is greater than 2. I'm shading y is greater than 2x, but I'm drawing the line y equals 2x. So y equals 2x, if you think about y equals mx plus c, this is the line with a gradient of 2 and a y-intercept of 0. So I know it's going to go through 0 and it's going to go up in 2s. So it's going to look a little bit like this, where we've gone through 0, 0, and then we've gone across by 1, up by 2, across by 1, up by 2, and we've got a gradient of 2. Now we need to think which side of that line has y coordinates that are bigger than 2 lots of the x coordinate, and all my y coordinates being big are up here, and all my x coordinates being bigger this way. So I want this side of a line. And again, you can just pick a coordinate. So if I picked this coordinate here, this is the coordinate 0, 3, and 3 is indeed bigger than 2 lots of 0. So you can just substitute in a point and that will help you. So we do want this side and we don't want this side. So I'm going to shade out everything on this side of the line. Some of it's already shaded from the other lines, but this would be the bit that I want, and we've labelled the region R. Oh, and that bit. Okay, question 16. Solve x minus 2 squared is equal to 3. So when I'm solving an equation, what we do to one side, we do to the other. I like to draw a dotted line to show. Now, first thing we need to do is square root both sides, but here is where people would go wrong. When you square root a quadratic, you need to think about the fact that it has a positive and a negative solution. So x minus 2 is equal to the positive and the negative square root of 3. And then we would add 2 to both sides. So x equals 2 plus or minus the square root of 3. Now if that was a non-calculator paper, my first answer would be 2 add root 3, and my second answer would be 2 minus root 3. But it says give your answers to 3 significant figures. So I'm just going to type that in my calculator. 2 add root 3 is 3.73 to 3 significant figures. And then 2 minus root 3 is 0.268 to 3 significant figures. So those are my 2 answers for this. Okay, question number 18. At time t equals 0 hours, a tank is full of water. Water leaks from the tank. At the end of every hour, there is 2% less water in the tank than at the start of the hour. The volume of water in litres in the tank at time t hours is Vt. Given that V0 is 2000, so we're saying at time equaling 0, there is 2000 litres in the tank. And Vt add 1, so the next hour, there is k multiplied by the previous hour. Now that looks really complicated. It says write down the value of k, and it's only 1 mark. It's actually not too bad. So to get to V1, to get to after 1 hour, what would we do? We would take 2000, which is our V0, and times it by 0.98. Because if it's going down by 2%, then we want 98%, and we know that to get 98% in our calculator, we multiply by 0.98 because that's 98% of the decimal. So all they're saying is to get to the next hour, VT add 1, it is K, which is your multiplier, times by VT, the one you're currently on. So this is now, this is how much water is in the tank now, and this is next hour. And that's all they're asking you. What would you multiply it by? What would be the value of K? And we can see that it is 0.98. Okay, question 20. OAC is a sector of a circle, centre O, radius 10. BA is a tangent to the circle at point A. BC is a tangent to the circle at point C. Angle AOC is 120 degrees. Calculate the area of the shaded region. Give your answer correct to 3 significant figures. So for this, I'm going to try and do the area of the whole thing, subtract the area of the sector, which is the section of the circle, and that should leave me with the shaded bit here. So let's start by getting the area of the whole thing. I know that this is a right angle here because a radius and a tangent meet at 90 degrees. And I know that this is a right angle here because, again, I've got a radius and a tangent. I know that this is 10. And so I know that this is an isosceles triangle with 10 and 10. We know it's 120 degrees in the middle here, which means that we've got 60 degrees left in our triangle. And since we know that these two sides are the same, we know it's 30 degrees here and 30 degrees here, which means that this angle is 60, this angle is 60, and so this angle would have to be 60 to add up to make 180. So at the top here, we've actually got an equilateral triangle. Okay, so what would be helpful? I can get the area of this bottom triangle at the minute, but I also would need to know the area of the top triangle, and to do that I'm going to need at least one of the sides so I can get 2 of the sides. Okay, so to do that I'm going to use the cosine rule in the bottom triangle here. So I'm going to say that this side, A squared equals 10 squared add 10 squared minus 2 times 10 times 10 cos 120. So that's the cosine rule. So 10 squared add 10 squared minus 2 times 10 times 10 cos 120. That is 300. So A squared is 300, which means that A is root 300. So that means that this side here is root 300. Also, this side here would be root 300, and this side here would be root 300. Because it's equilateral, all 3 sides are the same. So now I'm going to get the area of the whole thing. The bottom triangle, I'm going to do half AB sine C. So it's 120, 10 and 10. So half times 10 times 10 sine 120. Half AB sine C gets us the area of that triangle. Half times 10 times 10 sine 120. And that is 25 root 3. Oh. And I'm going to leave it in third form for now just because I'm going to go on and use that in a minute and I'd like to keep it accurate. And then I'm going to do the area of the top triangle. Let's do it up here. So I've got 60 degrees here. I've got root 300 and root 300. So we're going to do exactly the same thing. Half times root 300 times root 300 times sine 60. Now root 300 times root 300 is just going to be 100. So I've got 150 because I'm halving it, times sine 60, and that is 75 root 3. So adding that together, 25 root 3 add 75 root 3 is 100 root 3, and that's the area of the whole shape. That's the area of the quadrilateral. I'm now going to take off the area of the sector, so the section of the circle that we're interested in. I'm going to do pi r squared times 120 out of 360, and the radius is 10. So pi times 10 squared times 120 out of 360, or just a third, and that is 100 over 3 pi, 100 pi over 3. So I need to do 100 root 3, that's my total area, take away 100 pi over 3. So 100 root 3 minus that answer, and that gives us 68.485. So to three significant figures, my final answer would be 68.5. And what are we working in? Metres squared. There we go. And that's my answer for that. Well done if you got that. A very difficult question, and I didn't lay it out in the most friendly way because I was writing all over the place, but hopefully that made sense. Okay, question 22. The functions f and g are such that f of x is 5x add 3 and g of x is ax add b, where a and b are constants. G of 3 is 20 and f to the minus 1 of 33 equals g of 1. Find the value of a and the value of b. Okay, so g of 3 means if we change this x to be a 3, we get 20. So we know that g of 3 equals a times 3, so that's 3a, add b, and the answer to that is 20. So I've just changed the x here to be 3, and I know that that would make 20 as my answer. Okay, so that's the first thing we know is true. Now f to the minus 1 of 33, for that we're going to need the inverse function of this. So if f of x is 5x add 3, that is multiplying by 5 and then adding 3. So if you multiply by 5 and then add 3, the inverse of that, f to the minus 1 of x, the inverse function, is to take x, take away 3 first, that would undo the add 3, and then divide by 5. And they're saying if I put 33 into that, it's the same as g to the 1. So putting 33 into that inverse function, I get 33 take away 3 divided by 5, which is 30 divided by 5, which is 6. And so they're then saying that 6 is equal to g of 1. Now putting 1 into here, I've got 1a, which is just a, add b. And I've now got simultaneous equations, where I know that 3 lots of a add b needs to equal 20, and 1a add b needs to equal 6. So let's subtract them, and that's going to cancel the b's out. 20 take away 6 is 14, b take away b is nothing, and 3a take away a is 2a. So 2a is 14, which means that a is 7. And if I know that a is 7, and we know that a add b equals 6, 7 add b equals 6, and so b must equal minus 1. There we go. And we're done. Hopefully you found that helpful. If you've got any questions, let me know in the comments. Thanks!